Hi, let us look at question number 39. 4 electric circuits A, B, C and D using identical batteries and bulbs are shown below. Whenever we look at an electrical circuit question like this, what I tell my students to do is to trace the circuit pathways. What does it mean to trace the circuit? Let me show you. Tracing the circuit means to trace the possible pathways in which electric current can flow through. Let's start off with circuit A first. So there is one possible pathway in which electric current can flow through in circuit A. Let me show it to you. So this is how electric current is able to flow through in circuit A. In circuit B, how many possible pathways are there? There are actually 2 pathways. Let me show them to you. One is on the inside and the other one is on the outside. And now let's trace circuit C. In circuit C, there is one possible pathway. And for circuit D, there are 2 possible pathways. One on the inside and another one on the outside. Let's read the question now. A. Based on the diagram above, which 2 electrical circuits are the bulbs of equal brightness? So for this question, we need to find out the brightness of each bulb. The brightness of each bulb depends on the amount of electric current flowing through it. To find this out, let me teach you a simple analogy. Let's say Mummy has 3 sweets and Mummy would like to give the 3 sweets to her 2 children. How many sweets would each child get? This is simple math, right? We take the 3 sweets divided by 2 children, which means each child would receive 1.5 number of sweets. So for electricity, we can apply the same concept. And this is how we do it. Let's look at circuit A first. So there are 3 batteries in circuit A. Each battery gives out 1 unit of electric current, which means 3 batteries would give out 3 units of electric current. These 3 units would flow through the circuit, and in this circuit there is only one bulb. This bulb does not need to share the electric current with any other bulbs. Hence, it would receive all the 3 units and would light up with 3 units of electric current. Let's look at circuit C next. In circuit C, there are 2 batteries, so 2 units of electric current would flow through the circuit. However, in this circuit, there are 2 bulbs. Hence, the 2 units would need to be shared by the 2 bulbs. So each bulb would receive 1 unit of electric current each. Now, let's look at circuit B. As we have traced the circuit earlier and we realized that there are 2 possible pathways in this circuit. So let's look at the number of batteries first. There are 3 batteries, so 3 units of electric current. And the 3 units of electric current would flow through each pathway. So 3 units of electric current for the blue pathway and another 3 units of electric current for the red pathway. And in each pathway there is 1 bulb only. So it does not need to share the 3 units of electric current with any bulb. Hence each bulb would light up with 3 units of electric current. And let's do the same for circuit D. There are 2 batteries in circuit D, so 2 units of electric current will flow through each pathway. So each bulb would receive 2 units of electric current. Now that we know the brightness of each bulb in all the 4 circuits, let's answer part A. The bulbs with equal brightness would be the bulbs in circuit A and B, which is of 3 units each. So here is the answer to A. Circuits A and B. Let's look at part B now. Malcolm constructed another circuit with 2 rods P and Q of unknown materials as shown in the diagram below. He observed that bulb X and Z lighted up, but bulb Y did not light up. So bulbs X and Z lighted up, but bulb Y did not light up. So once again, let's trace the circuit to show the possible pathways in which electric current can flow through. So in this case, let's draw the first pathway first. Okay, so this is the first pathway, and this would be the second pathway. So there are two possible pathways in this circuit. Bulb X and Z lit up, which means there is electric current flowing through the blue pathway. Hence, was electric current able to flow through rod Q? Yes. So is rod Q a conductor of electricity or an insulator of electricity? It is a conductor of electricity because it allowed electric current to flow through it, allowing bulbs X and Z to light up. Now, why didn't bulb Y light up? It means there was no electric current flowing through the red pathway. Why is that so? It has to be because of rod P, and that means rod P did not allow electric current to flow through, which means it is an insulator of electricity. So let's look at the question now. Based on Malcolm's observations, state a possible reason why bulb Y did not light up. To answer this question, I'm going to introduce the 4 steps to answering electricity question. Step 1 is to state the situation. Step 2 is to state whether there is an open or closed circuit. Step 3 is to state whether electric current is able to flow through or pass through the circuit. And the last step, which is the 4th step, is to state the outcome. So now, as we know, the reason why bulb Y did not light up is because of rod P, which is an insulator of electricity. Let us use the 4 steps to answer this question. Let me show you the answer and we will discuss it from there. So let's look at step 1 first. As mentioned earlier, step 1 is the situation. In this case, the situation is rod P is an insulator of electricity. Step 2, we state whether there's going to be an open or closed circuit. So in this case, this causes an open circuit with bulb Y. Step number 3 is to state whether electric current is able to pass through or would not pass through. Okay, so in this case, it prevents electric current from passing through bulb Y. And step number 4 is the outcome. Thus, bulb Y did not light up. So this is how we use the 4 steps to answer electricity questions. Now let us look at part C. Based on your answer in B, state the possible material of rod P. As we have mentioned earlier, rod P is an insulator of electricity, which means it did not allow electric current to flow through. So what are some examples of materials which does not allow electric current to flow through? Some examples would be wood, plastic and rubber. These are examples of insulators of electricity. So here is the answer to part C. Either wood, plastic or rubber. Let's look at part D now. While shopping, Malcolm saw a sign with a faulty signboard as shown in the diagram below. Only letters E, I and T lit up, but letter X was not lit up. Explain based on circuit arrangement how the 3 letters E, I and T could light up even though X did not light up. So why do you think bulb X did not light up? Bulb X must have fused, which means the filament of the bulb might have melted, causing the bulb to fuse. Now we need to think of why the other bulbs are still able to light up even though bulb X has fused. It has to be because of the arrangement of the bulbs. There are 2 types of arrangement of bulbs. We have series and parallel arrangement of bulbs in the circuit. So for this circuit, what do you think is the arrangement of the 4 bulbs? If the bulbs are arranged in series, so let me draw 4 bulbs arranged in series first. So we have 4 bulbs arranged in series. What do you think will happen if one bulb fuses? So let's say if one bulb here fuses. If one bulb fuses, there will be a gap in this circuit here, which means there is going to be an open circuit with all the other 3 bulbs. Hence, when there is an open circuit, electric current will not be able to flow through the circuit and it will not flow through all the 3 bulbs, preventing all the 3 bulbs from lighting up. However, in this signboard here, even though one bulb, which is X, fused, the other bulbs were able to light up. So, what do you think these bulbs were arranged in? Could they be in series? No. So that means they would probably be arranged in parallel. So let me draw these 4 bulbs arranged in parallel. So when one bulb fuses in this arrangement here, so for example, if bulb X here fuses, will there still be an open or closed circuit with all the other 3 bulbs now? There will be closed circuits with all the other 3 bulbs. Electric current can flow through the other 3 bulbs just like this. And that is why E, I and T were still able to light up. So now we know the arrangement of the bulbs here. They are arranged in parallel. So since this is an electricity question, we would need to use the 4 steps to explain our answer. So firstly, we state the arrangement of the bulbs. The bulbs are arranged in parallel. Now let's start with step 1. Step 1 would be the situation, and in this case, the situation is that X did not light up. For step 2, we'll state whether there is an open or closed circuit. So when X did not light up, there will still be a closed circuit with the other 3 bulbs. And for step 3, we'll state whether electric current is able to pass through or not. So in this case, as there was a closed circuit with the other 3 bulbs, electric current was able to pass through the 3 bulbs. And step 4, we state the outcome. So this allows the other 3 bulbs to light up. So here is the answer. The 4 letters were arranged in a parallel circuit. When X did not light up, there was still a closed circuit with E, I and T, allowing electric current to pass through them. Thus, E, I and T could still light up. Thank you for watching this video. If you like my discussion, please click on the subscribe button below. And if you'd like to find out more about my analysis of other questions in this paper, do click on the videos on the right. Thank you, and I'll see you next time. Bye!